In this video, we're going to have a look at how you can extend Loadit by creating your own modules that plug into the software. Loadit comes equipped with a wide variety of modules built in, but what if you have some functionality that isn't covered by one of these modules? Well, that's where the extensibility of Loadit allows you to create your own modules that plug into the software. In order to start developing modules for Loadit, you need a .NET editor. I'm using Visual Studio here, and I'm using a solution that was created as part of the previous video where we created our own function. And now we're going to create a module that builds on our distance conversion example in that previous video. So the first thing you need to do, make sure that your solution references the Loadit public DLL, which is installed as part of the Loadit software itself. And then we've created a class distance conversion, which is going to represent the module that we're creating. So to get started, the first thing we need to do is import the relevant namespace from Loadit public. We're importing the inner modules namespace because we're creating a module, and you can see this contains a number of base classes, one for each of the different types of modules within Loadit. For today, we're interested in creating a transformation, so I'm going to inherit from transformation base, and you can see that Visual Studio automatically fills out placeholders for all of the functions that we need to fill in. There is a function configure, which is called when the module is configured, execute, which is called when the module is executed, and then there's a serialize and a deserialize method, which, as the name suggests, are used during serialization of the module when somebody saves the package. So the first thing we notice is that Visual Studio has highlighted an error to do with the constructor, and it's telling us that we need to implement a default constructor. So I'm just going to create a region for that, and we'll create a new constructor. And when we call the base constructor, we pass in a number of different parameters. The first is the name to use for the module, and that's what's displayed to the user in the user interface. A namespace, that's used to group your specific modules into one namespace to resolve any sort of naming conflicts. And a description, which again appears to the user as a tooltip and allows you to sort of describe what your module does. Just put in this module allows you to convert distances from and to different units. And then the last parameter requires that you pass in a GUID, a string containing a GUID, and this is to give each module a totally unique identifier, which is used sort of behind the scenes. So I'm going to take the deserialize and the serialize methods and just put them in their own region, just to tidy them away for the minute. We'll come back to those a bit later on and talk about those later. So then our first method is the configure method. I'm just going to put the configure and execute together into their own region as well to keep that tidy. Okay, so the first method we're implementing is the configure method, and we want to show the user a form. And this is the form that I've already prepared. So we want to prompt the user with that form and ask them to select a source column and the units to convert from and to in this example. So I'm going to need a member variable for the form. So I just declare that as config. Distance conversion config. Yep. So with that form variable available to us now, when the config method is called, we're going to prompt the user by showing the dialog, and we're going to pass in the available columns to the dialog so that it can put those into the drop down box. We'll come back to inputs a bit later on, but for now our logic is basically it's going to want to take the values from the form and populate some member variables. So we're retrieving the values from the form. I'm just cheating a little bit here with some code I wrote previously just to speed things up a bit. I'm just going to paste that in there and just tidy that up. So source units, target units, okay. So that then prompts the user, and if the user presses OK, it retrieves the values from the form and stores them in member variables. And if all that goes OK, then we return back to Loadit. We return OK as a return value, and obviously anything outside of that requires that we return cancel back to Loadit, and that's useful for Loadit because it will take a different action after configuration depending on whether you return OK or cancel. So if we build our solution and we put the extensions DLL next to the executable, so that's the extensions DLL that we've just created, when we run Loadit we should see that it picks up our extension and it finds within it the module that we've just created, and we can see that now appears within transformations. So we pull in some source data for transformations to use. I'm going to use our trusty old friend, the customer's data, and by dragging in the distance conversion module, you'll see after we've selected our data source, we're then prompted with the dialog that we looked at earlier. So that's great. Now I just want to jump back a sec and look at the inputs that we saw earlier. These are pre-populated for us, and Loadit is assuming that as this is a transformation, we're going to need one input and one output. And this is governed by the source rules, and you can override those by clearing the source rules and then adding in your own source rules. So if you want multiple inputs or inputs of specific types and so on and so forth, that's how you define it there. So then the last bit that we need to do is implement some logic that will get called when the module is executed. And because we're executing, we're expecting to output or produce some kind of output from this module. So to work with that more easily, I've imported the module IO namespace, which contains the module output class, which is the object type that each module outputs. I'm going to put a try catch here just to catch any errors. If there aren't any errors, similar to the configure method, there's a standard return value expected. So I'm going to return OK if everything goes OK, and I'm going to return failed if there's an exception. So to create my output, the output in this example is going to be based on the input that goes in. It's just going to have an additional column added to it with the converted values on it. So I can call the copy method of the incoming input, and that will create an output object for me to add into the list of the outputs for this module by calling the add output method. And then I'm going to add a column to the output to store the converted values that we're creating. And then from here, it's really just a matter of looping through all of the input values, doing the conversion, and then writing that value back to the output column that we've created. So I'm going to loop from the start of the rows to the end of the rows, and I'm going to set the output value, or set the value of column, the converted distance column on each row. I'm going to set that equal to the converted value according to some custom logic that I've got. Which I'm going to wrap in a method called calculate value. I'm going to use the source column member variable to determine which column to pull the values from. And as you remember, that was specified via the user specifies that via the UI, and then I'm just going to create a separate function that does the calculation we want, passing in the input value. Return a decimal value back in return. So the logic that can go into this function can be anything you like, and this is the real heart of where your module is going to do its work. I'm going to check for whether the input value is null, because obviously on any given row there can be a null value obviously, and if it is null I'm just going to return nothing as a return value. And then in here, rather than implement it for real, I'm just going to put 999 just to show that it's working, and just add the closing bracket here, and that's it. We just need to compile it and then execute it and see if it works. So we will drag a data source on, again using the customers again. We drag our new module onto the design surface, link it to the customer's data. We're prompted via our user interface. I'm going to select commute, convert from miles to kilometers, press OK, it whirs away, and our module has executed. We can tell because if we zoom in and look at the converted distance column that it's created, you can see it's filled with 999 values as we expected. So the last thing to mention is the deserialize and serialize methods, and these are called when the package is saved and when a package is opened. You can see these implemented in full if you download the SDK source code from the website. So that is a little introduction into how to create your own modules within Loadit. If you want to find out more, there's lots of information on our website, or why not get in touch.